Okay, can you guys see my screen?
Yes, sir.
Okay, thank you. So we are learning sampling, no? We are learning about sampling of a signal. So, so you know what is sampling already. You have idea. So if we simply talk, sampling is converting continuous time signal into a discrete time signal. So this is sampling. Okay. So if you present the model of the sampling, it is just like this. Okay. We have a sampler here. Okay. And we input continuous signal to the sampler and we get, this is continuous time signal as an input. Okay. And as output, we get discrete time signal. Okay, so this is the output. Okay, so this is the model of the sampling. Okay, so this is the sampling model. Okay, this is sampling model. So, so, so if we have, so in last lecture we have learned that this sampler, okay, this sampler, we can represent as a switch, no? We can represent as a switch. Okay, so this switch can be implemented using a transistor or manually, or there are many ways to implement this sampler or a switch in electronically. So simple way is to use a transistor, no? Transistor as a switch. Okay. So if we have this kind of signal, continuous signal, okay, continuous signal is like this, no? Okay. So this is T normally measured in second, and this is XT levels of the signal. Okay. So if this is the voltage signal, okay. So this is the variation of voltage with respect to time. Okay. Okay. So with certain time period, we will get, sorry, for certain time instant, okay, we will get some voltage value, no? We will get a voltage value. For example, if we get the time instant t1, we will get some voltage value, any voltage value. We don't know what is that, but we will get a voltage value. Say it is 2 volt. Okay, so at the time instant t2, again we get a voltage value. Okay, for example, this may be 5 volt. Okay, for instant t3, okay, time instant t3, okay, with this time instant, we will have another voltage value, okay, like this. Okay, so if you want to sample this, okay, if you want to sample this signal, you can simply send this signal through this kind of switch. Okay, so you can simply send like this. So you can feed the signal to this switch. Okay, and you can collect, okay, collect or plot, okay? You can collect or plot the sampled signal at the output, sampled signal at the output, no? So this is the sample actually. This is the sample, okay? So we have discussed this in previous week, okay? So we know that, so say at the beginning of this signal, okay, let's say it is time 0, okay, so this time instant is 0. Okay. So what is that happening? I'm not, I don't complain anything. What is happening? It is not for signal and system, no? Exam violation එක signal and system වලට නෙමෙයි වෙන්නේ නැති කියලා මම හිතනවා. කවිෂා?
සර් අද පාටිසිපන්ට්ස්ලා අඩුයි ඒ නිසා. ඒගොල්ලන්ට එකට කිව්වා මේක ඒ නිසා ලෙක්චර් එකට සම්බන්ධ වෙන්න මේ බැරි වෙන්නේ ඒ නිසා කියලා සර්ට කියන්න කිව්වා.
රයිට් රයිට්. නෑ මොකද්ද මේ exam violation inquiries එකක් තියෙනවා කියලා හින්දා මම ඇහුවා. signal and system වල නෙමෙයි.
නෑ නෑ.
හරි. signal and system වලත් හැබැයි complain කරන්න තිබ්බා කට්ටියට. හරි. Okay. Let's start our discussion. It is okay. I will upload this lecture so they can refer this. Okay. So if you have any problem regarding this lecture, you can send it to me. Okay. It is okay. Okay. So here you can plot the sample signal here. So for instance, so at t is equal to 0, say this switch is on. Okay, we close this switch. Okay, that means we will get a voltage value here. No, at this side we will get a voltage value here. For example, it may be 1 volt or something. Okay, so if we plot that one, okay, I plot it with respect to time also. Okay, not with respect to n. Okay, now I am going to plot it with respect to time also. Okay. So at t is equal to 0, this point, okay, so we will collect the voltage sample. Okay, so this is the voltage signal, so we collect the voltage sample. Okay, if this is a current signal, we collect the current here. If this is a power signal, in case of optical signal or something, okay, in case of optical signal, it is a power, so it will be a power signal. So okay, so we collect some kind of power here. Okay, so I get the voltage signal as example. Okay, so this xt is a voltage signal, so we collect the voltage value here. Okay, so say it is some value. Okay, so after t1 type, so then I just close it for an instant. Okay, I close this for an instant. I'm not going to hold it some time. I just close it for an instant, and then again it is open. Okay, so at that close instant, I can read the voltage value at this output. Okay, so I read it here. Okay, and again at t1, again I close this switch. Okay, then I read the voltage value. So at t1, so the voltage value is greater than this point, no? So I will get the voltage value like this at t1. Okay, likewise at t2 also I will close this switch for an instant, then I will collect the voltage sample here. Okay, then at t3 also I will close this switch and collect the voltage sample. Okay, so likewise I collect at, this is t2, this is t3, so at t4 again I collect a sample, at t5 I can collect a sample, t6 I can collect a sample, so on. Okay, So I can collect the sample. So this is the discrete version of the signal. Okay. So this is the continuous signal and this is the discrete signal. Okay. So, so now normally we know that discrete time signal we normally represent in n domain. Okay, not time domain. But this is, we call this is a discrete time signal. So this n also should be related with time, no? I have discussed this in previous lecture, so you can get it, okay? So follow that lecture, then you can get this idea, okay? So this n is somehow related with the time, and we know that, okay, I will tell it, okay? So here n is an integer value, okay? Not a decimal or something that t1, t2, t3 can be a decimal value, rational number, anything, okay? But these are discrete value because this point and this point, between this point and this point, there is no other value, okay? So these are discrete variable. T1, T2, T3, these are discrete variable, okay? But here n also a discrete variable, but it is an integer, okay? So it is 0, plus or minus 1, plus or minus 2, likewise, okay? So if the sample is, if the sample, if this is the 0th sample, the first sample we collect, okay, then the right side sample we consider as plus sample, and this left side sample we consider as minus sample, okay? So the sample can be plus or minus, okay? So we have n as an integer plus or minus integer up to infinity. So we have discussed this earlier, okay? So these are the number of sample, n is a sample. So this is the 0th sample. We have the 0th sample here. So this is the first sample, and this is the second sample, and this is the third sample, this is fourth sample, this is sixth sample, like this, okay? So if I plot it with respect to n, I will get 0. This is my first sample, and this is my second sample, okay? And this is my third sample, and this is my fourth sample, okay? And this is my sixth sample, okay? And this is my seventh sample. Like this, I can plot with respect to number of sample. Okay, 3, 4, 5, 6. Okay, okay. So, so we know that we can switch. Okay, we can close this switch with different interval. No, so this time interval here we select it as different. So we can select different time interval. Okay, so that means TS this T1. Okay, T1 and this time interval T2 minus T1, these are not constant. These can be variable. Okay, but we know that for simplicity, okay, for simplicity, we take this time gap as a constant. Okay, we get this time gap as a constant. Okay, so that is we get as TS. Okay, so between two sample, we get constant time gap, okay, as TS, okay. So this is a constant value. It is not varying, okay. So this TS here, and between this sample and this sample, it is TS, and between this sample and this sample, it is TS, and between this sample and this sample, it is again TS, okay. Okay, so we will get constant sample interval between two sample, and we call that uniform sampling. Okay, we call that uniform sampling. Okay, so this is a important word, uniform sampling. Okay, so uniform sampling means we get constant time gap between two sampling. Every nearby sample, we get a constant sampling time. Okay, So that is TS. Okay. So we call as this a uniform sampling. So you can see that, okay, in uniform sampling, okay. So this is the first sample and it is the T1 value, no? Okay. So we can, if this sampling time period is TS, we can say this T1 value as 1 TS. Okay. And this 2 is TS plus another TS. So this one is T2 TS point. And this T3 point is equal to 3 TS. And this T4 time instant is equal to 4 TS. Okay, and this time is equal to 5 TS, so on. Okay, so if we have n sample, what is the time instant of this at this sample? That is n TS. No? Okay, so that is equal to T, no? So we can say T is equal to n TS. Okay, and this n is number of sample. And this TS is the time between two sample, okay, and we called it sampling time. Okay, we called it sampling time. Okay, and we have another terms, that is sampling frequency. Okay, so what is that sampling time referred? What is the meaning of this sampling time? Can anyone tell? Can anyone just tell? It is okay. If you give a wrong answer, it is okay. So can you answer at least? Can one of you guys? Okay, so you can see that, okay. So this is the zeroth sample, no? So this is the zeroth sample, okay. So after TS time, we collect one sample, okay. Then again after TS time, we collect another sample. Again after TS time, we collect another sample. Again after TS time, TS time, we collect another sample. Okay, so that means with TS time, always we collect one sample. Okay, so at TS, we collect only one sample, no? So what is that? This is time for one sample, no? This is time for one sample. Okay, so what is always frequency? This frequency referred what always? Always referred per second, no? This frequency always referred, frequency is some kind of a rate, no? It is always referred to per second, okay? So sampling frequency always referred, sampling frequency is always referred to number of sample per second. Okay, so these are very important words. Okay, so you have to understand this. Sample frequency means number of sample per second. Okay, so we know that at TS time we get one sample, so at 1 second we get 1 by TS sample. No, this is sample per second. Okay, so this is the frequency, no? This is the sampling frequency. We normally denote it as Fs. Okay, so this is the sampling frequency. Okay, so here we have another. This one also one important factor. You have to keep remember this one. And second, Secondly, you have this one, that is if S is equal to 1 by Ts. Okay, so this is another important identity. So this is sampling frequency. So this is sampling frequency, and this is sampling time. Sampling time. If we describe this, sampling time is time for one sample, time for one sample. This sampling frequency always referred sample per unit time or per second, sample per second. So this is another important identity. Okay. So another thing is that, so this is xt. Okay, so this is xt, and we have, after sampled, we have xn. Okay, so after sampled, we have xn. Okay, so you can see that, okay, this t is equal to nts. Okay, so we can also represent that xt, okay, xt is equal to x nts. Okay, and this one also another important factor. So I think these three identity you can understand. Okay, okay, this one, this is the first one, and this is the second one, and this is the third one. So I think, I hope you can understand it. Okay. So another thing is, so for that is example. Okay, one example I will give the use of this sampling. Okay, the use of this sampling. So say we want to, okay, one use. Okay, I'm going to tell one use of the sampling. Okay, one use of sampling. Okay. So say that xt. Okay, we have this kind of signal, no? This kind of arbitrary signal. Okay, say we want to store this signal. Okay, we want to store this signal in a RAM. Okay, we want to store this signal in a RAM. Okay, okay. So say it may be Arduino board. Okay, it may be Arduino board. Okay, so Arduino board have a RAM. Okay, so we want to store this signal. Okay, okay. So we can code this Arduino board to store this signal. Okay, so we can feed this signal to some analog pin. Okay, then we can ask this Arduino board to store this signal. Okay, so how Arduino board will store this signal here? Okay, so if you want to store this signal, okay, store this signal at the Arduino RAM. If you want to, if the Arduino board try to, okay, if the Arduino board try to store all these signals, okay, so how many memory he will need to store all these point, how much memory he need? Okay, it is a practical problem. So I think some Arduino experts will be here. Okay, so can anyone tell how much memory he will need to install that kind of continuous signal? This is a continuous signal, no? So that means between, so you want to say you want to store it between from here to at this point after this time. Okay, so this is maybe 1 second, 1 millisecond or something. So you want to store. this signal from here to here with this length. Okay. For that purpose, how many memory you will need? How much memory you need? One word. So, tell me, do you want very big memory or small memory? Big or small? Large memory capacity, or you need to have small memory capacity? So can you tell that the memory that is required is large or less? So definitely it is large, no? Okay. I think I know that many of you know the answer. Okay. Because you are definitely you have worked with Arduino, Raspberry Pi, and many other processing unit. Okay. You know the answer, but the problem is that you don't answer. Okay. So anyway, definitely you will need very big memory, no, to install all this point. Okay, all this voltage point, you need very big memory. Okay, so practically we can't do it. Okay, so practically this is a digital system. So this is a digital system. Okay, so this is a digital system. So practically in a digital system, we can't record this kind of continuous signal. That is very clear. Okay. Okay. So in a digital system, we can't store the analog signal. Okay. So what is the solution? What is the solution? So solution is this. Okay. So this is the signal we have. Okay. And we will get some sample here. Okay. We will get some sample voltage of it may be a voltage sample like this. Few sample. We get some countable sample here. Okay. Then we can, so here we have some voltage value, 2 volt, 5 volt, 3 volt, 8 volt, something. Okay. So you have a RAM. Okay. So you have a RAM here, and in RAM you have like this memory location. You know that. Okay. So this each point you can store in one memory location. No? So store this to memory location, you have to convert this value to a binary form. So you have a decimal value here. You have to convert it to a binary form. Okay, binary form, 0101 like this. Then you can store it here. Okay, and this point also you can get. It may be a 5 volt or something, and you can convert it to a binary form, 101001 like this. Then you can save it another location, memory location here. Okay, and you can get the third sample, this one, and it may be 58 something. Okay, 8 volt something. So you can convert it to the binary, and you can store it here, another memory location. So that is the one use of sampling. Okay. So I am sure that you have already used this technique, no? So in Arduino board, you have analog to digital converter, inbuilt analog to digital converter. Okay. So I think in your laboratory works, you have done many Arduino works, no? So in this, you have analog to digital converter. So using this analog to digital converter, you can sample the analog signal and convert it to binary form, and you can store it in a RAM. Okay. So this is a one use of sample. Okay. So you can see that we always use this sampling techniques, okay, for our signal processing work. Okay. So I will give you 5 minutes for you, okay, and try to understand these three terms. After 5 minutes, we will start to do some question, okay. So get that time